Hi, my name is Patrick Thornton, and over the past several weeks, I've been researching high altitude balloons with my mentor, Munish Patel, an aerospace engineer at Lockheed Martin. To begin with, here's some background information. High altitude balloons are manned or unmanned balloons, usually filled with helium or hydrogen, and intended to reach near space, going as high as 11 to 23 miles high. For reference, outer space begins at an altitude of about 62 miles. The most common type of high-altitude balloons are weather balloons, but scientists, engineers, and hobbyists can also launch these balloons due to the relatively low cost of GPS and communications equipment. Modern balloons generally contain electronic equipment such as radio transmitters, cameras, or GPS receivers, and possibly also experiments. My mentor, Manish Patel, was introduced to me by Mr. Howell, as he was a former student. He went to Purdue for aerospace engineering and also completed a master's. During his career at Lockheed Martin, he mainly worked on spacecraft, starting off on commercial spacecraft like EchoStar, which is a satellite network, and also satellites that broadcast on BC. He then supported various military programs, including Advanced Extremely High Frequency, which is secure communications, space-based infrared systems, which are early warning system, and GPS. He was the chief engineer on GPS-3 for a while too. In speaking with him both through email and over the phone, I arrived at the decision to construct and launch a high-altitude balloon and document the process. The first step in the process was to figure out the materials used for this whole high-altitude balloon. The flight materials needed for construction were a balloon, a parachute, a radar reflector, a tracker, and some form of a payload, typically a science experiment or a camera. The actual launch then requires helium and a filling valve plus a tube to actually inflate the balloon. So balloons come in many shapes, sizes, and layers. Latex is the balloon of choice for many hobbyists because it's the most basic and easiest to use. In addition, it's a relatively inexpensive compared to other types of balloons. The price I could expect to pay for a balloon that could carry my simple payload is about $40 to $60. The parachute is vital for safe recovery, considering that these balloons go 59,000 to up to 121,000 feet high. Parachutes designed for amateur rocketry were recommended for balloon payloads as they work extremely well for just about any amateur balloon payload. About 4 to 6 feet in diameter is adequate to slow down the payload enough for a safe landing. A radar reflector is a device that makes your balloon payload visible to radar detectors used by civil transport and military aircraft. Many countries are required to be used on any balloon payload, including the United States. Reflectors are available for purchase online, but I can make one easily from cardboard and a reflective material like foil, which saved me plenty of money. Tracker is imperative for the balloon's recovery, as my efforts would all be for nothing if I couldn't locate where it landed or where it was during its flight. Commercial satellite and GPS trackers are reliable and easy to use, but a downside is that many of them have like caps on their altitude or their velocity, meaning they won't transmit their position. One of these reasons is so ordinary people can't just stick a GPS transmitter on a missile. Instead, we could also use radio-operated trackers, which don't have the limitation and are used extensively by amateur ballooners. The downside to this is that it requires a license for $15 and the transmitter. Due to its simplicity, I'll likely use a GPS tracker and receiver like the Spot Trace. It doesn't require a license to operate and performs flawlessly with no need for a heat pack. The only drawback is that it doesn't work above roughly 60,000 feet. The payload I intend to carry is a GoPro and the Spot Trace. The structure carrying all this will be constructed out of styrofoam and duct tape, with holes cut out for ventilation in the camera. On the outside, I'll include information from where the balloon came from and its purpose, so that I'll have contact information if it lands on someone's private property. Once everything is prepared, I'll need to run pre-flight predictions to get a general estimate of where my balloon will be traveling to. For launch day, when I'm finally ready to go, I'll have a team of friends with me to help with the whole process. Once in the air, the Spot Trace will send intermittent transmissions every 5 minutes, relaying its position to Google Maps. Typical ascent times are 1 to 2 hours, and the typical descent times are 30 minutes to 1 hour. Based on the wind patterns and jet stream, the typical distance traveled from the launch site can be anywhere from 20 miles to 75 miles. Due to the inconsistent nature of these balloon flights, I have to consider the plausible risk that I will lose the balloon's location or will land somewhere where recovery is impossible. Despite this failure and lack of camera footage from the flight, the whole process will still be a rewarding experience, no matter how it turns out. Unfortunately, due to a busy schedule and high workload from school and sports, I've been unable to put the entire plan into action during the school year. However, I've already made decisions on design and supplies, and once all the supplies ship and I find good conditions to launch, I'll definitely seize that opportunity. High altitude ballooning is a rewarding experience, especially for me because of my interest in aerospace, rocketry, and the expansive outer space. I'd like to thank Mr. Howell for introducing me to Mr. Patel, who told me all about his aerospace experiences, and also I'd like to thank you for your time.